Hey, what's going on, guys? Let's try this problem right here. Here we have a fiber optic cable, and the question is asking, if we shine a light toward the fiber optic cable, what is the maximum incident angle we have to have in order to make this light stay inside the fiber optic cable, right? Because after certain value it can go outside. Now let's see how we can figure it out. Now to find this one, we have to know the critical angle first. We have to find out the critical angle. Critical angle is basically when we have a certain angle, this will make the refraction angle will make 90 degree to the normal, right? So that's where the critical angle happen. That's what the critical angle is, right? Now let's find out the critical angle. So it's going to happen with this theta 3. So let's create an equation. N3 sine theta 3 is equivalent to N4 sine theta 4. So this theta 4 must be 90 degree. Theta 4 is the angle, the refraction angle, like with this normal. So that should be 90 degree in order to have a critical angle. Now let's go ahead and change this equation according to that. So this is going to be N3. Instead of putting sine theta 3, we can say sine theta c. So this is critical angle. And N4, and we know that this is going to be sine 90 degree, sine 90 degree, and we know that sine 90 is 1, so we can put 1 instead of this. So this, let's rearrange this equation. So this is going to be sine theta c is equivalent to N4 over N3. Therefore theta c is going to be equivalent to sine inverse N4 over N3, right? Now let's go ahead and plug the values. Sine inverse N4 is this index of refraction outside, that is AR 1, and then index of refraction inside the fiber optic cable, that is 1.5, and if you calculate this one, you should get 41.8 degree. So this angle is 41.8 degree, right? So theta 3 is equal to theta c, and that is 41.8 degree. Now let's see what's going to be this angle if this is 41.8 degree. To find that one out, what we can do is, since this is a right angle triangle, it's easy to find. Let's take this part alone. So this is going to be right here, and here we have theta 3, right? Maybe I draw this one a little bigger. Okay, so here we have theta 3, that's what we found out, and we are trying to find theta 2, and this one is 90 degree, right? Therefore theta 2 is going to be 90 minus theta 3, and if you calculate this one, you should get, that's going to give you 48.2 degree. So what does this mean is, this angle must be 48.2 degree or less than that in order to have this light to stay inside of this fiber optic cable. Now let's see how we can find the maximum using this one. Now let's use the Snell's law. Snell's law is N1 sine theta 1. Let's use a different color. N1 sine theta 1 is equivalent to N2 sine theta 2, right? Now we are trying to find theta 1, so let's rearrange everything. Sine theta 1 is going to be equivalent to N2 over N1, and then we are going to have sine theta 2 right here. Therefore theta 1 is going to be sine inverse N2 over N1 sine theta 2, right? Sine theta 2. So this is what we are trying to find. We are trying to find the maximum angle it should have. Now if we find this one, that's going to give us a maximum angle. Now let's see what we get from this one. Sine inverse N2 is what? This this one, index of refraction of fiber optic cable, that is 1.5 over 1 sine theta 2. We found out theta 2 is this angle 48.2 degree, 48.2 degree, and if you calculate this inside value, you will end up with 1.12, and we know that sine cannot be above than 1.12, right? So what does this mean is this maximum angle can be anything. It doesn't matter what angle you put. This, if you shine a light, it's always going to stay inside of the fiber optic cable. Now let's see whether it is true. We can try it with 90 degree, right? So let's plug 90 degree and see whether we get a number that is smaller than or equal to 48.2. If we take theta 1 as 90 degree, we have to have theta 2 that is this number or less than this in order to have this light inside of this fiber optic cable, right? Now let's see whether we get a number equal or less than that. Again, we are going to use the Snell's law. Snell's law, if we use again n1 sine theta 1 is equivalent to n2 sine theta 2. So here what we are trying to find is sine theta 2 during 90 degree. So let's flip this equation. N2 sine theta 2 is equivalent to n1 sine theta 1, and we are trying to find theta 2. Sine theta 2 is going to be equivalent to n1 over n2 sine theta 1, and therefore theta 2 is going to be sine inverse n1 over n2 sine theta 1, right? Sine theta 1. Let's plug the values. Sine inverse n1 is 1 over n2 is 1.5, and we are trying to find when sine theta 1 is 90 degrees. So let's plug the 90. That's just 1, right? And if you find this angle, you should get 41.8 degree. So it doesn't matter what angle we have, what incident angle we have. It doesn't matter what incident angle we have, the light will always stay inside of the fiber optic cable, and that's going to be the final solution. So the maximum angle can be it can be any angle, right? So there's no maximum angle, and that's how we do this kind of problems. I hope you find this video helpful. See you next time.